Hello everyone, welcome to today's class. Uh, let's start with a new chapter. The chapter is complex number, and we'll start with the basic of first of all the complex number. Okay, so let's first introduce what sort of numbers we have to talk about in this. Basically, we have to talk about square root of minus 1. Now, technically, if you know that inside the square root, a number always has to be positive. Means inside square root, negative number is not allowed. Then how can we deal with square root of minus 1? This is not a real number, first of all. It's a imaginary number. Means we cannot show this on number line. It doesn't exist that way. And this will be represented by iota. The symbol is I. So that means square root of minus 1 is I. And these kinds of number, which is imaginary, when combined with real numbers, they together known as complex number. Okay. So let's first of all deal with this iota. Let's learn about the powers of iota and how to deal with the basic operations of iota. Okay. So first of all, iota is nothing but square root of minus 1. If I square both the sides, what do you get? You get I square equal to minus 1. That's your first result. What about I cube? So I cube, I can rewrite this as I square into I. That means minus 1 into iota. That's minus iota. That means I cube is minus iota. Similarly, I can calculate I raised to power 4 also. That is I square into I square. Power gets added, 2 plus 2 becomes 4. So I square is minus 1. Another I square is also minus 1. Negative, negative, positive, so plus 1. That means I raised to power 4 is 1. Okay. What about higher powers then? So for higher powers, the general idea that we'll use, that I raised to power 4 into anything is always 1. Okay. So this particular rule will help you a lot. Okay. This one. And remaining, you should know that I square is minus 1. And I cube is minus iota. Okay. And I raised to power 3 is, or I raised to power 4 is 1. Okay. I'll rewrite this. I square into I raised to power 1. Okay. And I raised to power 4 into anything is 1. Okay. Now let's understand how do we deal with this. So I'll give you the key idea how to deal with iota. Treat iota as x. Means the same way you deal with x is the same way you have to treat iota. It's just that whenever you get I square, you replace that with minus 1. Whenever you will get I cube, you replace it with minus iota. I raised to power 4, 1. That's it. Okay. Let's solve few examples based on this simple idea. Okay. First one is 5 iota into minus 3 by 5 iota. So basically we have to treat it like x. Number will multiply it with number and iota will multiply with iota. So that means this 5 and 5 will cancel. So effectively you are left with minus 3 I into I becomes I square. And what is I square? Minus 1. So that becomes 3. As simple as that. What about this then? I raised to power 9. So for I raised to power 9, you can write this as I raised to power 4 into 2 plus 1. I can write 9 as 4 into 2, 8 plus 1. Plus I raised to power 19, I can write 4 into 4, 16 plus 3, 19. Now use the exponents rule that whenever power gets added, you can break down this in multiplication also. I'm using the reverse property of exponents. What is the property? A raised to power m plus n is a raised to power m plus a raised to power n. Sorry, not plus, multiply into a raised to power n. Whenever power base is same, the power gets added in multiplication. So I'm using reverse. So this is addition of powers. I'm breaking it in I raised to power 4 into 2 into I raised to power 1. This will become I raised to power 4 into 4 plus, not plus, multiply, sorry, habit of plus, into I raised to power 3. I hope this basic step is clear. Now all you have to do is deal with this. I raised to power 4 into anything, I raised to power 4 into anything is always 1. So 1 into iota plus this is again 1 into iota cube. I can replace iota cube with minus I. So this is I minus I. So what is like x minus x? 0. So I minus I is also 0. Okay. It's as simple as that. Okay. Third question is I raised to power minus 39. So same rule is still applicable. What happens with negative power? This is nothing but 1 by I raised to power 39. And now you have to write this 39 number as 4 into something. So I can rewrite this as I into 4 into, that's 9. 4 into 9 is 36 plus 3. So that gives me 1 by I raised to power 4 into 9 into I raised to power 3. Again same idea. I raised to power 4 into anything is 1. So I'm left with 1 by I cube. And what is I cube? That's minus iota. Now if you understand what is iota, it is square root of minus 1. And something you should know from the basic of mathematics, that we never leave square root in denominator. Yeah. So if I use this idea, so suppose for example I say you get 1 upon root 2, then how do you deal with that? You basically rationalize this, multiply with root 2, so you'll get root 2 by 2. Same thing we have to do here also. So if square root of number is present, so we multiply, in order to rationalize, we multiply by same square root. Iota is nothing but square root of minus 1. So I'll multiply both numerator and denominator with iota. Okay. We never leave our answer in the denominators in terms of iota. So 1 into iota is iota. Denominator minus I into I minus I square. So now what will this become? I square is minus 1. So iota upon negative of negative 1, that becomes positive. So iota only. So simultaneously I have dealt with the concept of rationalization also here. Okay. So whenever you get your answer in denominator in terms of iota, you have to rationalize. It's an unspoken rule. Okay. So I hope these first 3 basic examples are clear, and now you know how to deal with higher powers of iota also. So they can give you like I raised to power 99 also. Same idea. You try to write that at 4 into something plus something, and then break down using laws of exponent, and then 4 into anything is removed. Only I raised to power that remainder, which will be either 1, 2 or 3, can be easily solved. All right. Now if we talk about the basic operations of iota, other basic operations, still they are same. Means still we have to solve in a way that we are dealing with x. So suppose it was x, how you used to solve this? Open the brackets and then deal with it. So same thing you have to do, just multiply and open the bracket. So all the operations that you deal with the x in algebra, same thing has to be done here. So 7 into 3, 21. 7 into 3, 21 iota. Okay, whether you write iota into 7 or 7i, one or the same thing. Okay, 7 into I, 7i. I into 7i becomes 7i square. Okay, so 21 plus, we can add this, 21 plus 7, 28 iota. And what is this I square? I square is minus 1, so 7 into minus 1. So minus 7 basically. So we can deal with this too now. So 21 minus 7 is 14 plus 28 iota. That's your answer. What you can do is take out 14 common if you want, and this will become 1 plus 2 iota. So both are correct, both are the answer. Okay, depends what kind of option is given as such. So taking out common, multiplying, addition, subtraction, it is pretty much same as x, nothing new. All you have to do is deal with higher powers of iota. I square is there, replace it with minus 1. I cube is there, replace it with minus iota. Same thing here also, basic operations, addition, subtraction. So 1 minus iota, just open the bracket, because of this negative sign will change. So plus 1 minus 6 iota. Deal with number and number, deal with iota and iota. 1 plus 1 becomes 2. Minus 6 minus, sorry, nothing is present, so that means 1 is there, na? Like algebra. If minus x is written, that means minus x. So minus iota is written, that means minus 1 iota. So minus 1 minus 6, that becomes minus 7 iota. As simple as that. Okay. It's a easy chapter, particularly complex number, no? Even from objective point of view, this is easy, because all the basic operations are same. Same thing again here. 1 by 5 plus, you can rewrite this as iota into 2 by 5 or 2 by 5 iota also. Okay. Minus 4 minus 5 by 2 iota, and then deal number with number and iota with iotas. So minus 1 by 5, that becomes 20, minus 19 by 5 plus, this becomes LCM becomes 10. 4 minus 10, that becomes 4 minus 25, sorry, minus 21i. So that becomes 19 by 5 minus 21 by 10 iota. Okay. Another one, pretty much same idea, na? Still addition subtraction is going on. So bracket is there, so just follow the bracket, solve this first and then subtract this. So I'm not discussing this one, this has same idea, pretty much everything is looking same. Okay, so nothing new here. Take this as your homework, as an attempt. Try to solve this on your own. Okay, basic operation, deal iota with iotas, deal number with number, like x and number. Okay, now some basic identities. Okay, a plus b whole square, a minus b whole square, everything that you have learned in algebra is still applicable here. Okay, 1 minus iota raised to power 4 he is asking. So you don't know how to open a power 4 without the binomial help. With binomial, of course, you can, but right now let's assume that you don't know how to open power 4. So what you can do? You can rewrite this as 1 minus iota whole square, and then again square of it. Let's solve this 1 minus iota whole square. So we'll use the identity of a minus b whole square. So same basic identity, a square plus b square minus 2ab, so 2 iota, and then a whole square is there. So 1 square is 1, iota square is minus 1 minus 2i whole square. 1 minus 1 cancel each other, so minus 2 iota whole square. So square everything. Minus 2 whole square is 4, iota square is iota square, and what is iota square again? Minus 1. So 4 into minus 1, that's minus 4. Okay, next one, Again, very simple. A plus b whole cube. You know how to open whole cubes. A cube plus b cube plus 3 into a into b bracket a plus b. So 1 by 3 plus 3i. A cube, sorry, cube was there, no? Not square. My mistake. So a cube is 1 by 27. B cube is 27 iota cube plus this 3 cancels, so nothing but 3 iota is left, bracket 1 by 3 plus 3 iota. 1 by 27 iota cube. Okay, what do we have to do about this? We have to replace that with minus iota. 3i into 1 by 3, multiply this, you'll get iota, and then you have to multiply this and multiply this. 3 into 3, 9. So 9 iota square. Okay, so 1 by 27 minus 27 iota plus iota. I think we can deal with this now. Let's deal with this too. Minus 27 iota plus iota. This becomes minus 26 iota, and 9 into iota square becomes minus 9. You can deal with this. 1 by 27 and 9. So that becomes a large number. 1 by 27 LCM will become 27. 27 into 9, 729. 720. 729. No, not 729. That's, I think, 243. 9763. 3 2 6 9 2 18. 243. Yeah, 243. So 243 minus 243 plus 1, so minus 242 minus 26 iota. So very abrupt values coming because of this 1 by 27. No? So anyway, doesn't matter. I hope you know now that how to open the cube identities based on this, and you have to solve till you get something plus something iota. Okay, the idea is to get a complex number. Complex number is usually represented by z, and z is a plus iota b. You have to get a real number a and a imaginary number b. I'll talk about this. So you have to solve till that part. Okay. All right. Again, same thing. I think this one is also about cube, but this time minus 2 minus 1 by 3. So what you can do is take this as an attempt, try to solve this on your own. Okay, I'll give you one hint. What you can do is how to deal with that negative, because both the terms are given negative now. So what you can do, take negative common. This becomes 2 plus 1 by 3 iota, and then you have to cube this. So what you can do is, what is cube of negative? Negative. And now you have to do just cube of 1 by 3 iota. Iota is in the numerator, remember that. So just use, now you have to use again same thing, a plus b whole cube. That much you can solve. Okay, all right. Okay, now multiplicative inverse. So just give me one idea that what is multiplicative inverse of x? Any number x is 1 by x. Multiplicative inverse means something you multiply with that number and the result should become 1. Same idea is here. You have to find the multiplicative inverse of a complex number. So for 11th question, the multiplicative inverse of 4 minus 3 iota is nothing but 1 upon 4 minus 3 iota. But we never leave square roots in the denominator, and iota is nothing but square root. So if you want to look about this, it will look like this: 1 minus 4 into square root of minus 1. It's looking like this. Now, how do we rationalize this kind of expression? So my question to you is, forget about this. Just tell me, what if you get 1 upon 2 minus root 3 and you are supposed to rationalize this? How you can rationalize this? You'll multiply by changing the sign. That was the idea. This is like grade 9th maths. Okay. So same thing here. You change the sign that is present in the middle in order to rationalize. So we'll multiply this by 4 minus 3 iota. Sorry, change the sign. So 4 plus 3 iota, 4 plus 3 iota. Numerator is very simple. Multiply by 1 means 4 plus 3 iota itself. The denominator will always generate this identity a minus b, a plus b. That's a square minus b square. So that is a square, that is 4 square, minus b is 3 iota whole square. Okay. So 4 plus 3 iota in the numerator, nothing we can do about that. Denominator becomes 16 minus 9 into this iota square will become minus 1. So that means plus 9. So that becomes 4 plus 3 iota by 25. And if you want to separate the real part and the imaginary part, means you want to separate the number part only. So you can rewrite this as 4 by 25 plus 3 iota by 25. Okay. This is how you separate real and imaginary part. The one without any iota in it is called real part. Real part. And the one with iota is called imaginary part. Okay, so z is a plus iota b. That's your real part. B is your imaginary part. This is how we represent a complex number. Okay. The one with iota is called imaginary. The one without iota is called real part. Okay, so one multiplicative I haven't solved. This one is pretty simple, 13th one. Let's solve 12th one. Root 5 plus 3 iota. What will the multiplicative inverse? Now I'll write directly. It will be 1 upon root 5 plus 3 iota. And then when we have to rationalize. So root 5 minus 3 iota. Change the sign in the middle. Okay. Multiply with 1. So that remains same. Root 5 minus 3 iota. Denominator becomes root 5 square. That is 5 minus 3i whole square. That becomes root 5 minus 3 iota upon 5 minus 3 square is 9 and iota square is again minus 1. So that becomes plus. So this becomes root 5 minus 3 iota by 14. And if you want, you can separate root 5 by 14 minus 3 iota by 14. That's your answer. Okay. So multiplicative inverse again is just a way to teach you how to rationalize any complex number. Okay. And remember, it's the unspoken truth that you never leave iota in the denominator, like you never leave square roots in the denominator. For this one, I'll just solve it here because it's a very simple part. So multiplicative inverse of this will be minus reciprocal, 1 upon minus iota, and then multiply numerator and denominator with iota. This is what we have done in the example that was shown to you above. Okay, so iota into 1 iota, iota square. So that is nothing but minus of minus 1. So negative negative cancels. So that becomes iota. Okay. Fine. All right. Now, how do we actually get a complex number? So far we have talked about the basic powers of complex number. How do we rationalize it? How do we add them, subtract them, use the identities basic of algebra on the complex number, rationalize it. But point is, how it is actually being generated is using the quadratic equations, which earlier were not solvable. Okay. So let's talk about, I'll put the heading, solution of quadratic equation. How do they generate your complex number? Let's look at the first question. You need to have the basic formula of how to solve a quadratic equation. Like there was a big formula, na? Minus b plus minus square root of d upon 2a. If you even expand d was discriminant, it was b square minus 4ac, something like that. Anyways, if you don't recall, I'll tell you, but let's solve the first question and get the idea how and what kind of questions we have to deal with. So x square is plus 3 equal to 0. If you solve for x square equal to minus 3, first of all, what your common sense suggests is square of anything cannot be negative. Means we cannot actually solve this. So there is no real solution present for it. Now what you can do is take square root. If square is there, take square root on the other side. That becomes x is equal to, tell me if it is correct. Try to think, is it correct? Or still something is missing? I'll tell you, this is partially correct. Okay. Why? Because if x square is a, x is plus minus square root of a. A very common mistake. It's not square root of a, it's plus minus square root of a. Okay. So that means here it will be plus minus square root of minus 3. But square root of minus 3, there is no such thing. So what I can do is I can rewrite this as square root of minus 1 into square root of 3. Okay. So this becomes nothing but, what is square root of minus 1? Iota. So whenever you get negative number inside the square root, you just put iota and write the remaining number. So root 3 and iota is outside the square root. Okay. So whenever you get square root, negative number inside the square root, you replace the negative with iota and write the positive number. That's it. Okay. And the reason for plus minus I've written here. You can think of this like this is first of all a quadratic equation. Na? So quadratic equations should have two roots, not one. So one is plus root a, one is minus root a. Same idea here. Okay. So no formula is used. So good thing. But now the questions will be based on the formula itself. Second one. Minus x square. Let's put down some space. Minus x square plus x minus 2 equal to 0. First of all, I never like the coefficient of x square being negative. So I'll multiply this whole equation with minus 1. So x square minus x plus 2. Change the sign of each and every term. Doesn't make the difference here. I've multiplied both sides with minus 1 basically. Now it's looking better. Now in order to calculate this, you are supposed to do the Milton spreading. But for these kinds of questions, first of all, if it is somehow related with complex number, you will never be able to factorize it. Why? Try to calculate d. Remember d. d was b square minus 4ac. I'll write down with the color itself so you can remember this as a formula. Not sure if you remember this or not. d is b square minus 4ac. This was the d known as discriminant, and it can tell you whether you will have real solution, real and equal roots, or no real roots. So the no real root part was your complex roots or complex solution. So b square, b is, I hope everyone knows this, coefficient of x square is a, coefficient of x is b, without x the term is c. So b is minus 1, minus 4 into a is 1, into c is 2. So that's 1 minus 8, that's minus 7. d is coming negative, so no real roots, or precisely it is like coming less than 0. So we'll say therefore complex roots. Okay. Now how we calculate the solution of a quadratic equation? There is a big formula, no? So the formula was, again, I'll write down the formula. x is equal to minus b plus minus square root of d upon 2a. I tried to remember like this. At least if I remember b square minus 4ac inside this becomes a very lengthy formula. So this way it's slightly short. So if you want to learn this way, you can. Let's put down the values of minus b, d and everything. Let's calculate roots and see how the complex number are being generated. Minus b, so minus b, that is minus of minus 1, that's plus 1, plus minus square root of minus 7 upon 2 into a is 1. Now I told you what is square root of minus 7. Now like what is the square root of a negative number? Just put iota and write down the positive part of it. So this is 1 plus minus root 7 iota. Iota is outside the square root upon 2. If we want to separate this is become 1 by 2 plus minus square root of 7 by 2 iota. So two values of x which are complex number. So I hope this is clear. Let's look at one more question. Root 2 x square plus x plus root 2. Now these kinds of questions earlier they were very typical because you had to do middle term splitting of numbers and you still have to deal with square roots also. With the formula of d, this becomes actually very simple. So calculate d, that's b square minus 4ac. b is 1 square minus 4 into a is root 2. c is also root 2. Interesting. 1 minus 8, again minus 7. So again complex roots. So let's calculate x. Minus b plus minus square root of d upon 2a minus b. So minus 1 plus minus root of minus 7 upon 2 into a is root 2. So this time it becomes minus 1 plus minus root 7 iota outside upon 2 root 2. Okay, it's as simple as that. Means if they ask you to calculate roots for a quadratic equation and this is coming complex, it's actually very simple to solve. You can see there's no such complicated maths going on. Only step that you have to be careful about is this: how to deal with square root of negative number. Put iota, put root 7. Okay, done. One more, last one. Okay, fourth, what's the question? X square plus x plus 1 by root 2. So again, x square plus x plus 1 by root 2. It's your call if you want to deal with fractions also. Again, no judgment on that part. Or if you want, you can directly solve this also. So d, let's calculate. B square, that is 1 minus b square 1 square minus 4 into 1 into c is 1 by root 2. Now this is why it is problematic. That's why I don't like to deal with 1 by root 2. I prefer to take LCM and then generate an equation. Okay. But anyways, won't make much of a difference. 1 minus 4 by root 2. Now how can you generate this? You cannot, because 4 by root 2, even if you rationalize this 1 minus, this becomes, you rationalize this part, still it becomes 4 root 2 upon 2, that is 1 minus 2 root 2. Now how do you judge this, whether this is less than 0? See, root 2 is 1.41, so 2 root 2 is double of it, approximately 2.82. If you subtract 1 from if you subtract 2 root 2 from 1, basically that will generate definitely a number less than 0. So clearly again your d is negative here. Now this time what you can do is you can write x is equal to minus b, so minus 1 plus minus square root of d is 1 minus 2 root 2 Okay, so yes, square root inside square root upon 2a, 2 into 1. Now you'll think, why do we even have to generate a iota here? See, for this quantity, first of all, we know this is less than 0. That means what we can do, if I take negative common out of it, but it is still present inside the square root, it becomes 2 root 2 minus 1. Now at least this 2 root 2 minus 1 is positive. And what you can do is, because of this negative inside the square root, you can write iota. So minus 1 plus minus 2 root 2, one second, square root of 2 root 2 minus 1 iota upon 2. Okay. 1 by 2, 4ac na. So root 2 root 2, 2 root 2. It cannot be solved. You cannot get the exact value. If you want, you can get approximated value, but still, option can be like this also. They may, very less chance that they will give you in the square root of 2.2 root 2 minus 1, so 0.82, not like that. Okay. Anyways, I hope the idea to solve a quadratic equation and how the complex number are being generated is clear here. Okay. That was the basic of the complex number. So we have learned how to operate on complex numbers. Okay, so treat it like x, nothing else, and how to get multiplicative inverse, and more importantly, how to generate it using the quadratic equations. Okay. All right, that's it for today. We'll continue this chapter. There is still one part that I have to discuss, and there are a few terminologies related with complex number that we'll talk about in next class. Okay. All right, good day everyone. See you in the next class. Bye.